Okay, so the next result that I want to prove is that every context-free language has an equivalent planar pushdown automaton. So if this context-free language happened to be regular, then the result that we just proven about NFAs will also carry over because every NFA can be converted into an equivalent PDA. But the issue might be, well, what about if this context-free language was not regular, that needed to utilize a stack of an equivalent PDA? So of course there's a known result that every context-free grammar can be converted into an equivalent PDA. That's true, but it's not necessarily planar. So what I'm claiming here is that they can always be made planar. And it's actually very simple to see. The proof is very simple once you understand what the context-free grammar to PDA conversion actually does. Link in the description. If we look at the CFG to PDA conversion, what does it actually do? The conversion says we're going to make 4 base states. So here's my start state. This first one's going to push on a special symbol, then another transition to push on the start symbol of the grammar, the starting variable, then a state in the middle called QLoop, and then another final transition which pops off this $sign and pushes nothing, it doesn't really matter here, to the only final state of the entire machine. But of course, there's a lot of other transitions which involve a bunch of self loops right here, which are going to read any symbol corresponding to a terminal of the grammar and pop it off the stack and push nothing. And all of that happens at the same time. And of course, this happens for all A in the terminal set corresponding to the CFG. But of course, these are not all the transitions because we got to convert every single one of the rules of the context-free grammar into something in the PDA. Well, what happens is that we look at each of the rules and pop off the variable on the left side. So if the rule is A goes to x1, x2, up to xn, where this is the right-hand side, this is the left side, then we have a loop of transitions that corresponds to popping off A, the variable right here, because that's going to be appearing on the stack, and then all of this stuff gets pushed onto the stack in reverse order, but it doesn't really matter. It gets pushed on in a certain way. But the point is that when you do this conversion, it's going to look like this, a bunch of transitions that go out and come back. But if you think about it, we have a finite number of rules, and so what we can do is just make these loops that go out very, very thin and just have only one of them for each one of the rules. And there's only finitely many, so we can just make them as pinched tight, I guess, as possible. And so therefore, they don't interfere with each other. And those are all the transitions in the PDA. And since there's no edge crossings, this PDA is actually planar. That's pretty cool.